Hello and welcome to Cyber Hashira. It has been a while since I last made a video on OpenSSL. So today I have something new for you. Today's video is going to be about providers. Now, provider is a newly introduced feature in OpenSSL version 3. So first I'll talk about some of the changes in the architecture of OpenSSL 3, and then we'll have a look at the providers. I will also give you a quick rundown on the steps required to build OpenSSL 3 on both Windows and Linux. So yeah, that's what this video is about. Let's go. OpenSSL version 3 was released in 2021. It has been 2 years, so I'm not going to talk about what's new in OpenSSL. I'm sure there are other videos and articles that talk about it. I will start by talking about things that are going on in OpenSSL as of now. A quick update. The 5-year long-term support or LTS for OpenSSL version 1.1.1 is ending on September 11, 2023. This is something you need to be aware of. OpenSSL version 3.0 is the new LTS release. Support for OpenSSL 3.0 will continue till September 2026. OpenSSL version 3.1 will have a short-term support. The support for OpenSSL 3.1 will end on March 2025. OpenSSL version 3.0.8 has a FIPS module which has been certified by NIST. OpenSSL 1.1.1 did not have any FIPS module. The last version of OpenSSL to have its own FIPS module was OpenSSL 1.0.2. Now, before I get into OpenSSL providers, I'll start with the architecture of OpenSSL. As per OpenSSL strategic architecture page, starting from OpenSSL version 3.0, the existing as-is architecture will be moved to a future to-be architecture. Now, this is going to happen through multiple future release. The architecture used in OpenSSL 1.1.1 is the as-is architecture, which will eventually change in the future. OpenSSL expects the move to the new architecture to be completed by or before OpenSSL version 4. Let's have a look at the as-is architecture. The as-is architecture of OpenSSL consists of 4 components. I talked about them in my first OpenSSL video, so this may seem like a recap. The first component is application. Application is the command line utility itself. OpenSSL utility has the commands to generate keys and certificates and perform cryptographic operations such as signing or encryption. An application uses the OpenSSL libraries to perform those tasks. libSSL is a component which has implementation for TLS and DTLS protocol. libSSL uses the libcrypto library to perform various SSL TLS related cryptographic tasks. libcrypto is the core library of OpenSSL, which contains the implementation for all cryptographic operations and algorithm. It also contains implementations for protocols such as CMS or OSCP. Whenever you want to execute a command to generate a key or to encrypt some data, those operations are processed by OpenSSL with the help of libcrypto library. The fourth component is known as an engine. There's a video that I made dedicated to engines on this channel. Engines are used as an extension to libcrypto. They may contain algorithms and features that are not natively supported by OpenSSL. And that's the old as-is architecture used by OpenSSL version 1.1.1 and below. Let's have a look at to-be architecture. Starting with OpenSSL version 3.0, there is a new to-be architecture and it has some changes. Let's talk about those changes. Application is the same as it was for the previous version of OpenSSL. It has the same commands. Nothing is new here except for some new commands and changes introduced in OpenSSL 3. Common services includes various interfaces provided by OpenSSL which helps in building an application. For example, bio in OpenSSL can be used for basic input-output operation instead of writing your own logic. There's also EVP, which provides high-level functions for various cryptographic operations. I will talk about these services in depth in a video about OpenSSL API. The next component of OpenSSL 3 is protocol. These are just collection of protocols that OpenSSL supports. TLS, OCSP, CMS are some of the examples of supported protocols. OpenSSL 3 has also started supporting Certificate Management Protocol. OpenSSL has some functions that has been marked as legacy. They are not related to EVP. They are considered old and are deprecated. They are just there to provide backwards compatibility. And then there's core. Core is the component of OpenSSL version 3 that makes use of a provider. Whenever a cryptographic request is made, core looks for a provider that can process that request and then forwards that request to the right provider. There are 5 built-in providers in OpenSSL 3 and each of them have their own purpose. And now let's have a look at providers. It is something new that has been introduced in OpenSSL version 3. A provider in OpenSSL is a separate unit that provides an implementation for an algorithm or a cryptographic service. They are the same as Java security providers or Microsoft cryptographic service provider. Based on what an application wants to do, a crypto request will get processed by a provider. An application can request to use a specific provider, or OpenSSL would load a provider for that application. Let me give you an example. If you want to restrict your application to only use secure ciphers, then you can configure your application to use the FIPS provider. If you want your application to use an old algorithm, then you can configure it to use a legacy provider. Eventually, OpenSSL plans to replace engines with providers. So for now, engines still works with OpenSSL 3, but later in the future, engines are going to phase out. An OpenSSL provider can also be used by a third-party vendor to provide their own implementation of cryptography. They can write their own cryptographic solution as an OpenSSL provider. OpenSSL has 5 built-in providers. Each of them serves a specific purpose. Let's see what they are. These are the 5 providers in OpenSSL. Let's start with the default provider. Default provider, as the name suggests, is the default provider of OpenSSL. Default provider gets loaded when no other provider is specified by an application. A default provider is built into the libcrypto library, which means it has access to all algorithms provided by OpenSSL. Legacy provider is a collection of old algorithms which are no longer used or are considered insecure. Some examples of those algorithms are MD4, Blowfish, and DES. If an application needs to use any of those algorithms, then you need to tell your application to load legacy provider. The main purpose of legacy provider is to provide backwards compatibility. FIPS provider is used when FIPS compliance is desired. When an application uses FIPS provider, it can only use algorithms that are FIPS compliant. For example, your application can use AES or DES3 algorithm for encryption, but it will not be able to use DES key. OpenSSL uses a separate module or library for FIPS. This module is not installed by default. The FIPS module of OpenSSL version 3.0.8 is certified by NIST. Base provider has implementation for all non-cryptographic algorithms which can be used for serializing and deserializing a key. For example, DER encoding, PEM encoding, ASN1 encoding are some examples of serialization. Null is a blank provider. It has no implementation for any kind of algorithms, cryptographic or non-cryptographic in nature. This provider is built into the libcrypto library. The only purpose of this provider is to ensure that an application is not loading anything from a default provider. So if I don't want my application to load algorithms of any kind from a default provider, then I would configure and use null provider. I will now show you how to build and install OpenSSL from source with its FIPS module. The pre-installed version of OpenSSL may not have the FIPS module installed in it. So this is Ubuntu 22.04 virtual machine. This is a machine that I will be using to build OpenSSL from source. This machine already has OpenSSL 3.0.2 version pre-installed in it. Let's see what type of modules we have on this machine. So I'm going to copy this path and do cd. Okay, so the only module I have on this machine for this version of OpenSSL is legacy.so. If you remember, I talked about legacy provider. So this is the module for legacy provider. And if I run the command OpenSSL list dash providers, I can see that currently this OpenSSL is using the default provider. Let's go to the home. To build OpenSSL from source, we need the source. I'll download that source from openssl.org. I already have this open, so I'll copy the link and wget. Okay, it's downloaded. And now I will extract this package. So tar xf. And let's get into OpenSSL directory. Okay, so we have the content of the extracted file. Okay, so the first step is to configure the makefile, and to do that, I will run this command. It's config. Prefix is going to be opt OpenSSL, and I will set OpenSSL directory as again opt OpenSSL, and I want FIPS module. So for that, I'll just mention enable FIPS. I'll hit enter. Okay, makefile is generated. And now I will start the build process by running the command make-j. You should see an output similar to this one once the make command has completed. And now all I need to do is install all binaries. Now OpenSSL 3 has several ways to do that. So the traditional way is to run the command sudo make install. This is going to install everything. And by everything, I mean all binaries, the header files, the help docs, the SSL directories, everything. If I want a lighter installation, I can run the command install SW. So this is just going to install the software components such as the binaries, the header files, engines, and the modules. The module directory will not include FIPS. If I want even something even lighter, I can run the command install runtime. This is just going to install the OpenSSL application along with the binaries. And if I want to install the FIPS module, I can run the command install FIPS. For this exercise, I will just run the command sudo make install SW, sudo make install FIPS, and sudo make install SSL dirs, and I'll hit enter. Okay, this should have everything I need. So if I run the command tree OpenSSL, here it is. So this one has the header files, the search directory, the bin directory, which has the OpenSSL application, the lib directory, which has the engines, the lib crypto file, libssl. Then there's a OSSL directory, and inside OSSL directory, we have a FIPS module. So FIPS.so, this is the FIPS provider. Legacy.so is the legacy provider. And we have some other files. There's also a way to uninstall what we have installed. So all I need to do is replace install with uninstall. So I'll just do uninstall. Hold on. Uninstall and uninstall. I'll hit enter. And this is going to remove everything that we installed. So now if I run the command tree opt OpenSSL, these are some leftover files. Most of the things are already uninstalled. Okay, let me put everything back together. Perfect. I will now test the newly installed version of OpenSSL. So opt OpenSSL pin OpenSSL version -a. Okay, we are getting an error. I can fix that by running the command export ld library path and pointing it to the lib64 directory inside opt OpenSSL. Let's do it again. And we have the right output. It's 3.0.9. And I'll go into my home directory, open profile, export path equals opt OpenSSL bin and $path, and I will also export ld library opt OpenSSL lib64. Okay, save the changes and source. Okay, and now we have 3.0.9. Okay, I will now show you how to build and install OpenSSL from source on Windows. Now, if you have watched my first OpenSSL video, I taught you to build OpenSSL using Visual Studio. Now, that method required you to install Visual Studio on your computer, which takes time to download and install if you're doing it for the first time on a computer. And then you would have to install Strawberry Pearl and NetWide Assembler. Today, I'm going to show you a method which is much easier to follow. I'm going to use a program called MSys. So this is the website from where you can download this program, msys2.org. If you scroll down, here's the installer. You can download the installer from here. They also have instructions on how to, install the program. And so this is the program that I will be using. I already have it installed on my machine. So here it is. This program kind of reminds me of Cygwin. If you're using this program for the first time, then you would need to install the GCC compiler and make. I already have the command. Let me copy it over here. So pacman-s, this is the command, the same command that is used on Arch Linux to install packages. So I'm going to install mingw. This is the GCC compiler and the make package. So I'm going to hit enter. Yes, package is installed. The next thing I need to do is download the OpenSSL source. So I'll copy this link and wget paste. Okay, source downloaded, tar xf OpenSSL. Okay, tarball has been extracted. Let's get into OpenSSL. And now almost everything I do is same as that I do on Linux. So I would run the command configure and mingw64, and we need the prefix. Prefix is going to be c:/OpenSSL. OpenSSL directory is going to be c:/OpenSSL. This is where I want my OpenSSL to be installed, and I want the FIPS module. I'll hit enter. So this is going to configure the makefile. Okay, makefile is configured. Now I need to run the command make. So I'll do make-j and wait for this to finish. Okay, make it successful. It took some time to finish. And now all I need to do is run the command make install. And this is going to install all the build binaries into C OpenSSL. Let's wait for this to finish. Make install has completed successfully. And now if I take a look in the C drive, we have an OpenSSL directory, and I ran the command make install, so it just like installed everything. And in the bin directory, we have our OpenSSL binary. So if I run the command OpenSSL version-a, OpenSSL 3.0.9, and everything else. Now that I have built and installed my own OpenSSL program from source, I will now show you how to configure providers in OpenSSL. So I will run the command OpenSSL list-providers, and this command should be able to get the list of all providers that are currently available. This is a freshly installed OpenSSL, so that's why we only see the default provider. If I want to configure more providers, then I have to make some changes in the configuration file of OpenSSL. So for that, we'll go to opt OpenSSL. Before you make any changes, it's always best to run the command OpenSSL version-a so that we can see the path where we need to make the changes. So the OpenSSL directory is, for me, it's opt OpenSSL. Once I'm in the OpenSSL directory, I would run the command sudo openssl.cnf. Once I'm in this file, I will scroll down till I see a section that says OpenSSL init. So under OpenSSL init, there should be an entry that says providers equals provider sect or provider section. And here's the provider section. Under that, we see default, and it says default sect. Let's start with legacy provider. So we have default, and let's configure legacy. So I'm going to type legacy equals legacy sect, and I'm going to create a, let me add some space here. Okay. So legacy sect activate equals 1, and I'm going to save the changes. Now if I run the command OpenSSL list-providers, I see the legacy provider. If you still remember what I said about legacy provider, they have all legacy algorithms which are too old or not secure anymore. One of them is MD4. Let's see what happens if I try to hash a file using MD4. So for that, I will create a file. This is a simple text, and I'm going to throw this file into the temp directory test. Okay, OpenSSL MD4 test. And we are getting MD4 hash. Okay, all well. Let's try SHA-1 temp test. Okay, I am getting an error. It says unsupported. So it just says that this algorithm is not supported. Let's try something older than SHA-1. Let's try MD5 temp test. Again, I am getting an error that says unsupported, which means MD5 is not present inside the legacy provider. So currently, OpenSSL is configured to use the legacy provider. MD5 and SHA-1 is a part of default provider. It comes from libcrypto, and because default provider is disabled as of now, that's why I'm not able to use SHA-1 and MD5. Let's now activate default provider, and I'll disable legacy provider, and let's see what happens. So sudo nano openssl.cnf. Scroll down, here's legacy. I'll disable this, and I will activate the default provider. Save the changes, OpenSSL list, providers, and now it says default instead of legacy. Let's try OpenSSL SHA-1 temp test. Okay, SHA-1 works. Let's try MD5, which was failing. MD5 also works. Let's try MD4, which is a part of legacy provider. And for MD4, now I'm getting that error that says unsupported because OpenSSL is currently using the default provider and MD4 is a part of legacy provider. The procedure to configure base and null provider is the same. So all I need to do is do sudo nano, go into OpenSSL.cnf, and I'm going to configure all four providers. I'll show you how to configure FIPS provider. I'll save that for the last. So default legacy base is equal to base sect, null equal to null sect. Okay, and so we have default sect, legacy sect, base sect, activate is equal to 1, and we need null sect, activate equals 1. Save the changes. Now if I run the command OpenSSL list, providers, I am getting all four of providers displayed on the screen. So I have base, default, legacy, and null. Now I will show you how to set up a FIPS provider. The procedure to install FIPS provider is a bit different, and that's why I wanted to do this last. So the first step is to generate a FIPS configuration file. There's already one present in the OpenSSL directory, so I'm just going to update it, and the command is OpenSSL FIPS install -out, and I'm going to output this into the file that already exists. I'm just going to update it. And the module that I'm going to use is opt OpenSSL. It's present in the lib64 OSSL module directory. And the name of the module is fips.so. I'll hit enter. Okay, I'm getting failed to, oh, sorry. I need to sudo it. Let me clear the screen. All right. So sudo. Okay, installation passed. Let's go into opt OpenSSL. Sudo nano OpenSSL.cnf. Okay, so here in the configuration file, first you need to uncomment this line and just mention the complete path. So opt OpenSSL / name of the file is fipsmodule.cnf. And I'm going to create a new section for FIPS. So it's FIPS equals FIPS sect. And I will create a new section for FIPS. So this is going to be FIPS sect activate equals 1. I will save the changes. And now if I run the command OpenSSL list -providers, I see the FIPS provider here. So now we have 5 providers: base, default, FIPS, legacy, and the null provider. Okay, I will now show you how to configure OpenSSL to only load the FIPS provider. So for that, I would run the command sudo nano and OpenSSL.cnf. I will scroll down to the provider section and I will disable default, which has all algorithms in it. Does not matter if it's secure or not. I will disable legacy because it has all old algorithms in it and all of them are insecure. Base has all non-cryptographic algorithms in it. Null does not have anything, so I'll just disable it. And FIPS has all cryptographic algorithms which are considered secure by NIST. So OpenSSL is going to use the base provider and the FIPS provider. I'm going to save the changes. Let's run the command OpenSSL list providers. And now I see base and FIPS. Once again, base provider does not have any cryptographic algorithms in it. The algorithms that it has are all non-cryptographic in nature. FIPS has all cryptographic algorithms which are considered secure by NIST. So that's why I'm using it. All right, let's do a test. So for this test, I'm going to use SHA-256 and the file is in the temp test. Okay, no problem with SHA-256. Let's try SHA-1. No problem with SHA-1. Let's try MD5. And for MD5, I'm getting an error that says unsupported, which means MD5 algorithm is not supported by FIPS, and that's why I'm getting this error message. Let's try something else. So let's go to the temp directory for this. I'm going to generate a key. So gen rsa-out rsa.pri, and the size of that key is 2048. Okay, no problem with 2048 size key. Let's try 1024. Okay, for 1024, I am getting an error that says invalid modulus, and it is complaining about the length. 1024 is considered as a weak length by NIST, and that's why this size is disallowed. Let's see what happens if I enable the default provider. So sudo nano opt openssl.cnf, and I'll go to the provider section. Okay, uncomment defaults. I want to enable default and disable base. So now we have default and FIPS provider. Save the changes. OpenSSL list providers. I see default and FIPS. Let's generate a key again. So OpenSSL gen rsa-out rsa.pri and 1024. Okay, no problem with 1024. How about 512? No problem with 512. So at the moment, OpenSSL is making use of the default provider. All cryptographic requests are getting forwarded to the default provider. And default provider allows keys of size, RSA keys of size 1024 and 512. However, if I disable the default provider, so default is disabled, and I'm going to enable base. Save the changes. Let's try again. 1024 fails, 512 fails, 2048 works. That's all I have for you in this video. I hope you learned something new from it. Also, remember to check out the GitHub link that I have included in the description. It contains the notes that I have made for this video. And before you leave, please leave a like if you like this video and consider subscribing to my channel if you're new here. I have more videos on OpenSSL coming soon. Thank you so much for watching and take care. Bye bye.